Welcome back, everyone. We are up to lesson 3 of unit 6. No new lesson notes. So we're going to get right into the examples. A bicycle wheel has a 1-foot radius. The wheel rolls to the left counterclockwise. Now, the part about this having a 1-foot radius is important because if we go back to the lesson notes, some of the lesson notes from lesson 1, this is an example of what we call a unit circle. A unit circle is a circle with a radius of 1 that's centered at the origin. So this wheel, by saying it has a radius of 1, is a unit circle, okay? And the reason why that's important is going to become clearer as we move on. So number 1, what is the circumference of this wheel? So the circumference, you should know already what the circumference is. The formula for circumference is 2 pi r. And in this case, the radius is 1. So the circumference is going to be 2 pi feet. So what is the circumference of this wheel? 2 pi feet. Okay. Number 2, mark the point Q where P will be after the wheel has rolled 1 foot to the left. Be prepared to explain your reasoning. So with a unit circle, with really any circle in general, okay, we talk about angles as we go around the circle. So the point directly to the right of circle is always going to be the 0 degree or the 0 radian. The point directly up from center is going to be 90 degrees or pi over 2 radians. Directly to the left of center is going to be 180 degrees or pi radians. Directly down from center is going to be 270 degrees or 3 pi over 2 radians. And then when we get back to where we started, that's going to be 360 degrees or 2 pi radians. Okay? And when we talk about an angle, within the circle, okay, if we call that angle A, okay, what we know is if that A is measured in radians instead of degrees, as it says here, angle A is the same as the length of the arc cut off by A. So the arc is just a section of the circle, a section of part of the circle. If we go all the way around the circle, it would be 2 pi. But if we go around part of the circle, we call that part an arc, okay? So in other words, the angle in radians is equivalent to the number of radii it takes to go that much around the circle. So in this particular case, what they're asking for is if we go 1 foot, if we have an arc length of 1 foot, so when the wheel rolls 1 foot to the left, what they're really saying is that the arc length is 1 foot. So they're asking us which one of these points would be equivalent to 1 radian, okay? Well, I know that this is 0. I know that this is pi over 2. I know that this is pi, and I know that this is 3 pi over 2. And then when we get back to the end, that's 2 pi. So 0 is 0. Pi over 2 is approximately, if we calculate this, pi over 2 is approximately 1.57, okay? So what that is saying is that the length of the arc a quarter of the way around the circle, so the length of this arc is about 1.57 feet. So if this whole thing is 1.57 feet, because that's pi over 2, that means 1 foot's going to be just short of that. So 1 foot we can say is going to be about right here. Because if this is 1.5 feet, this would be 1, this would be a half, and this would be 0. So we'll call this point, says point Q. Now again, how did I get that? Okay. How did I get that? If we go back to the lesson notes again, the arc length is the same as the angle in radians. So I know that directly up from center is pi over 2 radians, which means that that quarter of a circle, that arc, a quarter of the circle, is going to be pi over 2 feet. Well, pi over 2 is about 1.57. So 1 foot is going to be just short of that. So that's how I got that. Okay. So that's number 2. Number 3, I'm going to do in a different color. Mark the point R where P will be after the wheel has rolled 3 feet to the left. What angle in radians does P rotate through to get to R? Okay. So if I'm going pi over 2, okay, that's a quarter of the way around of a circle. If I go pi feet would be a semicircle. That would be going halfway around the circle. Now I know that pi is 3.14, right? So 3 feet is going to be just before that. So let me get yet again a different color. So 3 feet is going to be just short of that. So we'll say that that's about right here. And we're going to label that point R. So that arc that's in yellow would be 3 feet. It's just short of pi feet, which is 3.14. Again, I used the same reasoning as I did for number 2. I know that halfway around the circle is pi feet because pi is directly to the left of center. Pi is 3.14, so 3 feet is going to be just short of that, so just short of halfway around the circle. So I marked point R. Okay, what angle in radians does P rotate through to get to R? That's going to be an angle of 3 radians. Again, the arc length is the same as the angle in radians. Okay. Where will point P be after the bike has traveled pi feet to the left? Well, we've kind of already answered that question. Okay. Pi feet, okay, would be the same as an angle of pi. So let me write that up here. Pi feet, that means an angle of pi radians. And an angle of pi radians is directly to the left of center. So directly left of center. So where will point P be after the bike has traveled pi feet? It will be directly left of center. Okay. What about 10 pi feet? Okay. This one's a little trickier. Okay. Pi feet would be left of center. 2 pi feet would be directly to the right of center. So that would mean going around the circle one whole time. That would mean the wheel has done one complete revolution. So every time the wheel does a revolution, a complete revolution, that's 2 pi feet. So 4 pi would be 2 revolutions. 6 pi would be 3 revolutions. 8 pi would be 4 revolutions. 10 pi would be 5 revolutions. So 10 pi feet, that point would be directly to the right of center, right where we started. Okay? because every time the wheel does a revolution, it's 2 pi feet. Okay? So at 100 pi feet, it would be the same thing, because 10 pi would be 5 revolutions, 12 pi would be 6 revolutions, 14 pi would be 7 revolutions, so on and so forth. So 100 pi would be 50 complete revolutions of the wheel. So the point, again, would be right back where it started, directly right of center. Okay? So the points, it said to mark them on the circle. So I'll use a different color. The points would be right here where we started. Okay? After traveling some distance to the left, the point P is at the lowest in its rotation. So the lowest in its rotation would be, once again, use a different color. I'll just use black this time. The lowest point in the angle of rotation would be down here. Okay. The lowest point in the angle of rotation that's directly down from center, that's an angle of 3 pi over 2 radians. So the angle is 3 pi over 2 radians, which means the distance is going to be 3 pi over 2 feet. Okay, so 3 pi over 2 radians means 3 pi over 2 feet. So to reiterate the point of this lesson is introducing the fact that these angles here, that 0 radians is directly right of center. That's our starting point. 90 degrees pi over 2 is directly up from center, so on and so forth. It's introducing that and introducing this concept that the angle is equivalent to the length of the arc. So an angle of pi over 2 would mean that this arc, if it were a unit circle, is pi over 2 feet. This would be pi feet, so on and so forth. So the angle is always equal to the length of the arc in radians, which is why going all the way around the circle is equal to 2 pi radians. Okay, so that is it for this lesson.